No. I was not a YouTuber.
We're an editor.
Okay, here we go. Focus, focus. So, we know that one way to check if these fractions are equivalent is to do what?
Bottoms up.
Bottoms up. Cross multiply. So, I multiply 3 times 2, that's 6. And then 6 times 1, that's 6. Right?
Yeah,
we already know how to do this. We did this last week. You are experts.
This is the easiest one.
A lot of us had a hard time making peace with these 6s. We were like,
Wow.
okay, but why? Like, yes, I multiply, but why does this 6 represent 1/3? And why does this 6 represent 2/6?
It's just the answer.
But why? We don't know. That's an abstract. That means like you just know it because you know it,
Yeah.
right? So what we're going to learn today we're going to learn the concrete way, like the visual way. It's just like when you learn your times tables and you learn 2 times 2 is 4.
Yeah.
Why?
You already, I don't know. You just know it.
Because there's 2 groups of
Because 2 groups of 2 is 4.
When you
So
count.
knowing 2 times 2 is 4, that's your abstract. Knowing that 2 groups of 2 is 4, that's your concrete. So today we're going to go over the concrete, the visual of how to figure out if these fractions are equivalent. Now, again, remember the first time we do anything, it's usually a little tricky. So don't start. I don't get it. I don't get it. What?
That's
What?
how we always do
Hold on.
That's all like.
We're going to do it a couple of times. Okay? And then we'll see how you feel.
Alright.
So, step number 1. Step number 1 says label rows and columns. This has not changed. This is just like when we used to do area models. Remember? So, this time, your first fraction is your rows. And then the second fraction is your columns. Step number 2. Oh, let's rewind. We know that rows go side to side and my columns go up and down. The rows are side to side, like row, row, row your boat gently down the stream. The ocean waves go side to side. And the columns go up and down like the columns at the White House. Remember? Okay. Step number 2 says draw a rectangle for each fraction. So I'm going to draw a rectangle to represent 1/3. Nope. And then I'm going to draw another rectangle to represent 2/6. Now this one I'm going to make it like medium size. Not super big where it takes over my whole entire paper, but big enough so that I can see what I'm doing. So the first rectangle represents the fraction 1/3. The second rectangle represents the fraction 2/6.
This takes up most of the page.
You're not writing this down, you're not going to understand it. You get to write them during recess. Okay. Now I'm going to draw my rows and columns. That's step number 3. Draw rows and columns. So for each rectangle, I'm going to draw how many rows and how many columns. Yes? Remember your rows are 3 because the numerator names the number of the chosen ones. Denominator tells the total of the parts. So my denominator tells me how many total rows I should have. So I should have 1, 2, 3 rows. And I'm still going to do 3 rows on this second one. The first fraction dictates my rows for both. So 1, 2, 3 rows. Now, I'm going to draw in my columns. We're not looking at the numerators. The numerator names the number of the chosen ones. Denominator tells the total of the parts. So this denominator tells me how many total columns I'm going to have. This is going to be 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So I have 3 rows because of this fraction and 6 columns because of this fraction. Now I'm going to go back to my first fraction. The numerator names the number of the chosen ones. So in this fraction that indicated my rows, there was 1 chosen one. So in this fraction, 1/3, 1/3, I'm going to shade in 1 row. Now it doesn't have to be perfect. Remember that in math, we just color to mark. Now in the second fraction, the numerator names the number of the chosen ones. The second fraction dictated my columns. And it says I have 2 out of 6 columns. So I'm going to shade 2 out of the 6 columns. So to go back to this part, somebody had told me, why did you put shade in rows and shade in columns into 2 different steps? Because shade in rows is only for this figure. Shade in columns is only for this figure. If I put shade in rows and columns, it sounds like it's in the same one.
Yeah,
So I wanted to make that separate.
It'd be like you do one up and
And then
one down.
exactly, and I didn't want you to do that.
And it'll make no sense.
The last step says count all the shaded squares. Yes? So I'm going to count 1, 2, 3, 4, 5, 6. So 1/3 equals 6 squares.
Oh.
Now the next one. 1, 2, 3, 4, 5, 6. 2 6 equal 6 squares. So this is telling me that if I were to represent this fraction in a figure that was cut up like this is how much I would shade. If I were to represent this fraction in this figure, this is how much I would shade. I shaded 6 squares. I shaded 6 squares. What does this tell me about these fractions?
They're equivalent.
They're equivalent. Now remember the 6's that we got up here when we cross multiplied? That's where those 6's come from. Now there's a lot of steps to this strategy, but this explains the why. Why are we cross multiplying? Cross multiplying is just a hack, but it gets you the number of squares.
Yes, I like it takes
Okay.
away less time.
Now the beauty of this one is that you don't need to do any multiplication. All you do is count.
Miss, but the multiplication.
The beauty of the other one is that
it takes like
you just
a minute.
multiply.
It takes
right?
like a minute.
It's just
Both are good. It's good to do this one and then check it with your butterfly, your cross multiply. Okay, it's a good checks and balances to see that you're on the right track.